Okay, so last time I guess because I already know all of you, I didn't even think about going over the syllabus. So that's the first thing we're going to do today is go over the syllabus. I didn't even think about it until after we left. The syllabus is on D2L and it's all basically the same as last semester, like information of how to contact me and all sorts of those things. You don't have to buy the textbook. We did talk about that last time because it's all available online. The grading should be pretty similar to last semester. There are more projects reflections. So like when I say more projects, it's like not as big as the project as you did last semester, but like more smaller projects. But still same idea of 2 exams, a comprehensive final exam, and then everything else is pretty much the same. I do have like the schedule, the game plan of the schedule. So we will do exam number 1 before spring break. And then exam number 2, do y'all I don't know if y'all have presentations in your 362 class. Do y'all have
We have
exams?
One, but we're not presenting.
Is your exam before spring break here?
I don't know.
You'll look at it and figure that out. I'm happy to move this to Tuesday or whatever we need to, so you don't have 2 exams back to back on the same day. So check your exam 1 there. I did kind of bump this up so that we did the review and exam on week 13 and then presentations on 14, because usually people do exams on week 14. So if the exam ends up falling the same day, I'm happy to move it forward or backward a day, whatever works best for everybody's schedule. The study days. So on review week, we will meet on Tuesday for final exam review. We will not meet that Thursday because it's the study days. And then your final exam is on the 9th, which I think is Thursday from 10:30 to 12:30. Questions about that at all? Or comments, statements, anything about that? Okay, so I have, so a lot of you are online today. The syllabus is online, but if you want a copy of it, I have a copy when you come to class this time. So feel free to ask for that. Okay, so last time we talked about Egyptian numeration. So the Egyptian number system. Today, we are going to move on and talk about the Babylonian number system.
I have a quick question about the homework.
Yes.
On 7B,
I have a question on that one too.
Okay, let me pull it up just a second. I have it actually in the book. I don't have to hold it that way. Okay, 7B. Let me
you'll
see.
need the transcribing, whatever, of the symbols, but yeah, because if you look at the second number, it has the comma, which says it's going to be in the thousands place, but the symbol afterwards is that little, that's not a single digit number.
That'd be the tens place. Like that's a tens place digit, right?
Yeah, so that's where I was like, how does that work? Because I thought if it was like a 10,000, then you use the B or the M. So that's where I wasn't quite sure what the number would be.
I agree. Yeah, I see that. Let me see. Sorry, let me look over here. I thought I had this uploaded. Let's just omit that one. How about that?
Okay.
So omit 7B.
Okay.
I don't know if that's a typo. I would think it's a typo because my thought process is if you were using the comma to multiply by thousands, why would you have a whole idea of how you do 40,000? You know what I mean?
Right.
Like, why would you do the whole M thing if you could just do that instead? So again, a person actually wrote this textbook, like a person that we know. So not saying it's not a credible textbook, but there may be more errors in here just because of that. So let's just omit 7B and I'm going to circle it and I'm going to look at the key because I've already made the key for this. I did it last time I taught this class. So I'll look at the key and see and maybe come up with a better answer for you on that one next time.
Okay.
But just go ahead and omit it for now.
Okay.
Okay.
Everybody wants to leave.
Either one. Any other questions on the homework?
Question mark on 12F. Only because I got to really on
12F.
population.
Well, sorry. 12. Oh, convert this. No, that would be a really big number because the 2 lines means you multiply by 1,000 squares. So yeah, it'd be a huge number. So yeah, you're good. Should be a huge number. Okay, so we're going to talk about the Babylonians and their numeration. So Babylonians and their number system. Okay, so the Babylonians are like the people group that live in Mesopotamia. It's at the same time period as the Egyptians. Okay, so it's around 3,500 BC. So same as the Egyptians. They just live in 2 different places, so 2 different people groups. And one of the differences between the Babylonians and the Egyptians is what they wrote with. So the Egyptians, wrote with, they carved into stone, and then once they moved past that, they wrote on the papyrus. So the Babylonians, they did not carve into stone. They had clay tablets, and they had a stylus. Okay, so to write, they used a stylus and clay tablets. So let me see if I can pull a picture of what the stylus looks like. Stylus? Yeah, stylus. Let's see if it comes up. Cuneiform. So it was the stylus that they could put 2 different, so this is kind of what the writing looks like, but there was 2 sides of it. So one side made these longer things, and then the other side made these like smaller triangles. So it made 2 different like impressions that you could use to write your numbers. Okay, so the impression, oh, and the other thing is the clay dried really fast. So since it dried so fast, like most of the writings were short, like they weren't very long, but they were basically indestructible whenever they were baked. Okay, so clay dried fast. So the writings or the tablets were short. But indestructible when baked. So this is like a really important idea, this idea of the fact that they're indestructible when they're baked, because something that was created that long ago could last a very long time, and so we can still know about it today. There's other people groups that we don't know much about, and we'll talk about that at the end of class, just because they didn't have a writing system that could stand the test of time, is the idea. So this writing system could stand the test of time, and so we have a lot of information and know a lot of things about their people group. So their stylus had a sharp end and then a back end. So we have 2 different shapes, or a sharp end and then a base. So the 2 different shapes that you could create was a line. I always just draw it like this with like a triangle on top. I think the picture kind of looked more like that a little bit. It's kind of up to you how you want to write it. So that's one version, and then the other version, or the other symbol, is just the triangle. So the idea is it kind of feels like, I mean, you can only make 2 symbols that way, but this, depending on which way it's facing, you could make it face up, you could make it sideways, you could make it face down like that. You can make it face the other side. I did that wrong. This way. So just that symbol alone could be turned different ways to represent different things is the idea. Later, the symbol was added. So it looks something like this. And there's not really a name for these symbols. But the name of all these symbols, so the name of their like writing is called cuneiform. So CUNEIFORM. So that's the name of like the symbols is cuneiform. And we are going to learn to write numbers in cuneiform today. Okay, so let's talk about their number system, and we're going to understand their number system first, and then we're going to learn how to write in their number system. So the Babylonian number system is the first positional number system, and that's kind of a big deal. So they're the first people group to have a positional number system. Number they have a sexagesimal number system, which is a base 60. Okay, so this is like, if you know anything about number systems, Babylonians are very famous for this. So it's called a sexagesimal system, which means it is base 60. So let's kind of familiarize ourselves with the base 60 number system. We have a base 10 number system. So to go up to the next digit, we have digits 0 through 9. For them, the idea, it's digits 0 through 59. And so in the first place value, this would be 60 to the 0 power, like the ones place. So you could put any number 0 through 59 here. And then once you bump up to the next place value, that's 60 to the first place or the first power. So if I want to write the number 62, it'd be a 1 in this place value and then a 2 over here. Does that make sense? So I have 1 of these and 2 of these, and we'll practice that in just a minute. And then this would be 60 to the second power, so on and so forth, 60 to the third power, yada, yada, yada. So let's practice writing some numbers in base 60. So we're going to go from base 10, which is our number system, and write it in base 60. And once we get the idea of the math behind it, we'll start putting the symbols on it. So let's write the number 28. How to write the number 28 in base 60.
28.
Yeah, it would just be in the ones place. It would just be the number 28. Right? If I wanted to write the number 257. This time, how many digits am I going to have in my answer? Like how many place values am I going to have in my answer? So let's look through, for it to fit in this first place value, this is number 0 through 59, right? Like the ones place. This is what we would like call our tens place or whatever. 60 to the first power is 60. This 60 to the second power, to bump up to that one, what is 60 times 60? 6 times 6 is, yeah, 3,600. So once you get up to the number 3,600, you're starting to write in here. So 3599 to 60, we would use this place value. or I said that backwards, 60 to 35.99, I'm gonna be using these 2 place values. Numbers bigger than 3,600, I'm gonna use 3 place values, so on and so forth. Does that kind of make sense? So the number 257, I need 2 place values for it.
But is it
So-
really, are you really using it as an exponent or is it just?
The 60 to the 0 to the first to the second, is that what you're talking about?
Yeah,
And that's kind of relating it back to every base is written like that. Like in our base 10 system, we have the base of 10, 10 to the 0 power is the ones place. This is
Right.
the 10s place. This is the hundreds place. This is the thousands place.
but I'm
That's-
just, it just seems
ahead.
like that's a huge jump in the second. Like, wouldn't it just be 60 to 119?
So
Then you
let's
would
do a couple
go-
problems, and I think it's gonna answer that question.
Looking at it. when we-
Okay, so let's do a couple problems and it'll make some sense. So this number 257. How many 60s can I get out of that number?
One.
How many times does 60 divide into 257? I brought my calculator just for this.
4.
Yeah, so 257 divided by 60 is 4. So I can get 4 of these out of it.
Plus over.
And then, so now
You're not
257,
actually writing, you're just, it's like you're multiplying 4 times 60 and
yes,
adding what's in the
yes.
other.
Yeah, so there's 17 pieces left, so that would be the number 17 right here. So this seems real dumb to us because we don't put 2 digits in 1 place value. But if I don't do it this way, otherwise I'm gonna have to use like letters and symbols. We'd be spending more time doing that.
So in the first place, I mean, we interpret that as 6 times 40.
Yes, it's 60 times 4
Or sorry, 60
plus
times 4.
1 times 17.
And do
Just-
you always put it over the 60? Or do you
Yes.
typically just put a space, like you put like this?
Yes, and we'll talk in just a minute about more notation. I'm just trying to like just talk about the math now and not put in all the notations and all these things. Oh, sorry, was it all this stuff yet?
Okay.
So back to our place value system, the number 295, it's 2 times 100 plus 9 times 10 plus 5 times 1. This is just so normal to us. We don't even think about, I have to do 2 times 100. It's in the hundreds place, so it's 200, right? It's the same idea, but it doesn't make quite as much sense because I'm not doing by tens or
by
hundreds or
60.
thousands. Okay. So to do the number 257, I have 4 60s and 17 ones. And 4 times 60 plus 17 times 1 adds up to be 257. Does that make sense? Okay, let's do a bigger number. So let's say that's number 2. Number 3, let's do 5,287. Oh, real fast before we do this. In our place value system, since it's base 10, I'm only allowed to put the digits 0 through 9 in each place value, right? I couldn't put like 11 in the hundreds place because that would be 1,000 and 100, right? It's the same idea here. I can put the number 0 through 59 in this one. I can put 0 through 59 in this one. I can put 0 through 59 in this one. I can put 0 through 59 in this one. If it's more than 59, you got to bump up to the next one. So the idea for this one, if I just thought this again was like a 2-digit number, 2 place value number, 5287 divided by 60, there's 88 of those. So it's going to be a 3 place value number because I can't put 88 right here because 59 is the biggest number I can put right there. Does that make sense?
So you need to know. Something.
Yeah, so like kind of idea is 60 to the first power is the ones place. The next place value, to the 0 power, I said ones power, sorry, 60 to the 0 power is ones place. The next place value up is 60. So a number smaller than 60 would only use this place value. The next one up from here is 3,600. So a number smaller than 3,600, you'd only use these 2. The next one up after that is 60 to the third power. So 216,000.
So I know that when you divide 6 by 5,287, you get the 88. But what exactly does that tell you?
That means it would be 88 things in this position. I have 88 of these 60s, but I can't have 88. I need to bump up to the next place value. Just like I can't have 12 in one spot, I have to bump to the next place value. So since this number is in between 3,600 and 216,000, it's going to be a 1, 2, 3 place value number. Okay, so I'm gonna go ahead and put my 3 place values here. This is my ones place, 60 to the 0 power. This is my next place value up. We would normally call it the tens place. In this case, it's the 60s. I don't know what you would call it. And then this would be 60 squared. So generally, the easiest way to do is start off with the biggest thing. How many of the biggest things can you make? So 60 squared is 3,600. It takes 3,600 pieces or whatever to make that place value. How many of those do I have?
One.
Just one is the idea. Because when I do try again.
There's not another place.
The fourth place value, you have to have this many pieces to make it.
Like a minimum.
A minimum of 216,000 to make it. So I only have one of these in this situation. And then now I figure out how many leftover pieces I have. So 5287 minus 3,600 is 1687. Do you remember doing this in elementary math or whatever? Math for elementary school teachers. So now I have this much left over to make this. How many 60s can I make out of that? 1687 divided by 60 is 28. So I can make 28 of those. And when I make 28 of those, I used up 1,680 pieces is the idea. And so I'm left with 7 pieces left. So a 7 would go there. So the idea is 5,287 is 1 times 60 squared plus 28 times 60 to the first power plus 7 times 60 to the 0 power. Or another way to think about it, that is 1 times 3,600 plus 28 times 60 plus 7 times 1. And I keep on saying pieces. It's whenever I teach this, we usually start off with manipulatives and we don't do base 60. We do base 3 and base 2 and base 5. And the picture of that, if you think about base 10 blocks. So if I go back over here to my base 10 blocks, this is like the unit. This is the long, right? And it takes 10, I'm not going to draw that very well. I'm just going to kind of sketch it. It takes 10 of these units to make the long. This is the flat. It takes 10 of the longs. This is terrible drawing to make the flat, right? Like this. You know what I'm talking about? Base 10 blocks. Yes. And this is the cube, the big, huge cube with all the pieces in it. It's the same idea. So like 10 of these make that, 10 of these make that, 10 of these make that. The idea for base 60 is this is a huge long one that has 60 pieces. This is a huge one that has 60 this way and 60 this way. So it's like a huge version of this. So that's kind of the picture if you want to relate to base 10. Okay, so go ahead.
I just wondering why they chose 60. So
We'll talk about that in a second. Yeah, we're talking about that next. So questions about this one? Let's do one more bigger than that. Number 4, if we had 105,102.
I think you still would go out 3 place values.
You still would only go out 3 place values because to have 4 place values, it has to be a number 216,000 or bigger. Everybody agree with that, or does that make sense? So it's still going to be 3 place values. 60 to the 0 power, 60 to the first power, 60 to the second power. So how many of these flats or 60 to the second power can I make? It takes 3,600 pieces to make one of them. So I can make 29 of them. It's the most I can make. So I can make 29 of them. 29 times 60, wrong, I did that wrong. 29 times 3,600 is 104,400. So I need to see how much is left after I make that. So 105, 102 minus 104, 400. And I get 702 left over. How many 60s go in that? So 702 divided by 60, there's 11. I can make 11 out of that. And let's see, 60 times 11 is 660. So I have 42 left after that. And so that's just going to be the pieces in that part right there. So you can check your answer by doing 29 times 3,600 plus 11 times 60 plus 42 times 1. And that should add up to be 105,102. Does that make sense? Are there questions about that at all? Anybody online have questions about that? Okay, so that's the first part on your homework today. You'll do a few problems like this. The way our textbook writes these numbers so that you don't have to put like the place value blanks every single time, they separate these, not fractions, like they separate these place values with commas. So this number would be the number 4,17 to show the difference in the 2 place values. If you want to write it like this, I'm totally fine with that also. I don't care either way, but I think later on it'll make you go the other way. It'll give you this number and want you to write that, which is the easiest. Like we did the hard thing first. That's actually easier. Okay. So how would I write this number with the commas? Yeah, 1,28,7. And then this would be 29, 11, 42. It's faster to write it that way, but if it's confusing, feel free to put the blanks in there or whatever. Okay, questions about that? Okay, so this whole number system was confirmed on a tablet that we found in 1854. So we discovered this whole number system in 1854. And that specific tablet that we discovered all this from, the way we figured it out was, so this numbers, I'll write this all down. And as we get a little further past all this, I'll come back and kind of remind you of the highlights. So again, I'm not expecting you to memorize that this number system was founded by us in 1854. I want you to know it's a base 60 place value system. It's the positional number system. Like I'll tell you kind of what we need to take away from it at the end. Okay. So don't unless you want to memorize it, don't feel like you have to memorize every single thing that we're writing down. Okay. So this number system was founded by us in 1854 from this tablet, and the tablet had the squares from 1 to 59. So it contained squares from 1 to 59. So it was easy to read squares from 1 squared is 1, and this is again in cuneiform, like this is not in our numbers, this is with all the symbols, all these symbols, and we'll go over that in a minute. So 2 squared is 4, all the way up to, this is where 7 squared was still easy to read. It was still the number 49, and we could easily read that. And then 8 squared was represented with this 1, 4. Why would it be represented with 1, 4? Because this is the 60 to the first value or first power place value. And this is the ones, the leftovers. So that's kind of how we figured out was base 60. Once you kind of figured that out, you could check it with the rest of them. 9 squared said 121. So 60 plus, that's plus 21 gives you 81. So that's how they figured out it was a base 60 system. So let's, now that we kind of understand how their system works. Yeah, I have a story about, like a drunken story about the people who discovered all this. We'll talk about that at the end. So let's talk about how we're going to write this stuff with cuneiform. Okay, so writing with the cuneiform. So this is with like the notation and the symbols and stuff. We have 2 different symbols that we use, and you can spend a lot of time drawing them like we did here with all the triangles and all that. I am going to simplify it a little bit. So this one we are going to write with a T is the idea, to make it go faster so you're not drawing triangles over and over and over on your paper. And this one we're going to use like a less than sign for it. So in our numbers, I need to be able to write, kind of going back to this, I need to be able to write the numbers 0 through 59. Would you agree? Every number I can write as some number through 59 in this place value, some number through 59 in this place value. Like 59 is the biggest number I have to write. So the way that we write that, we use the T as basically like the 1, and it can be written up to 9 times. And then we use the little less than sign as like a 10, and it can be written up to 5 times. So if in some place value, I wanted to write the number 23, the way I would write that in cuneiform would be 2 10s and then 3 1s. So 2 of the arrows and then 3 of the T's. And generally, I don't know if this is always forever, but generally the T's, like the number 59, the biggest number, you usually see the T's written in groups of 3. So kind of like that. And then the arrows, it's usually 3 on top and 2 on bottom. If you want to write them all out, I don't care. But this kind of saves a little bit of space if you kind of stack them on top of each other. And you'll kind of get the hang of that as you go through. Okay. So again, we write number, or they wrote numbers in the same order as we do, the bigger digit on the left, the smaller digit on the right. So let's kind of practice looking at what numbers would look like. So for example, if you had this number, so let's do 2 arrows and let's do 5 of the T's. And then let's do 4 arrows and 2 T's. Oh, sorry, you can't see that very well. So this number in cuneiform, how many place values do I have? It's like, here's 1 place value, here's 1 place value. Okay, so this would be the like 60 to the first place value. This would be like the 60 to the 0 place value. And the number in this place value is 25. Because I have 2 10s, 5 1s. So this would be the number 25. This would be the number 4 10s, 2 1s, 42. So for us, that number would be 25 times 60 plus 42 times 1. $25 times 60 is 1,500 plus 42 would be 1,542. So that would be the number 1,542. Does that make sense?
I could have missed it, but why does 60 have the 1 for 25, but then 60 has 0 for 42?
Going back to our place value, this is like the ones place, and I can have up to 59 ones place there. This is what we normally call the tens place. In this case, it's any number between 60 and 35.99 fits, like it has that place value. So it's like how many, and going back to the picture, this picture, it's how many pieces it takes to make the base 10 or the base 60.
I
This
think
takes
I'm
one piece.
confused because I thought that in the original thing that we were doing that were 2 separate numbers, but you're saying that it's
Oh, on this
one
problem.
number. Yeah. So is
Yeah,
that how
this
you
is just like how you
designate-
would write one number right here.
You would put a
And
line.
so the place
in
values are
between?
kind of separated by, I mean, there's not a line here. I drew the line there. But you can tell, like, since this is like tens place, ones place, that's going to be some place value. This is tens place, ones place, that's going to be some place value.
So because
That
it's just
kinda makes sense.
continuous.
Yes.
Yeah, because I
And
thought
we'll-
initially you were doing 2 separate numbers, but then you
Oh,
were
okay.
putting a place
I see what you're
value.
saying. I probably shouldn't have
but-
put the line there. That makes it look like 2 completely separate things. So yeah, this is just like one number.
Okay.
And in just a second, we'll talk about like how that's very confusing. So, I mean, it is obviously because y'all are confused. Let's practice doing the cuneiform with these numbers we already did. How about that? And kind of get the hang of it. And then maybe it'll make a little bit more sense as we go through and do some other problems. So let's take this number 257. Or actually, let's do 28 first. We didn't really, that was the easy one, so we didn't do much. So the number 28, you would just represent that with 2 arrows and then 8 T's. 5, 6, 7, 8.
You can do 10 teams or 9.
9, yeah. Because after 10, you go up to the arrow thing. So that's how you would write the number 28. Because it has one place value, so I'll write it like one number here.
And you represent 60, 0, 28. 28. 16.
Or actually, if we're using the commas, the answer would just be 28. And that's it. Because there's no place value other than that. It all fits in the ones place.
For the zeros.
60 to the 0 power equals 1. So that's why I call it the ones place. The units place or whatever you want to call it, I guess.
Right.
For this number, 257, there's 2 place values. So 4, I would write first. How would I write 4 in cuneiform?
2 T's? Or
4
4
T's. Yeah, so 4 T's. And then how would I write the number 17 in cuneiform?
1 arrow.
1 arrow
7 T's.
and 7 T's. They read that as like one number like that. So
So really the divider that is the fact that you go from the T's to the arrow.
that's exactly what I was about to say. Yeah. So we'll talk about some other dividers they kind of had in a minute, but the divider is the fact that I go from a T to something bigger, like an arrow after that. So let's do the next one, 128.7. How would I write the 1?
T.
Just a T. How would I write the 28? 2 arrows and 8 T's. Dadgummit, I'm running out of room here.
How do you go?
I'm gonna like finish it on this paper right here. So now 7 T's. You would just draw 7 more T's. And the idea is, remember, I wouldn't add up 8 and 7 T's to make 15 T's, right? If I wanted to say the number 15, I would put another arrow over here. So you'd automatically know like this is now the next digit over there.
But you know, if it's the next digit, that's not how you wrote it. What if you wrote it all on a straight line?
That's actually one of the problems we'll talk about in just a second. So give me just a second, we'll talk about it. So this last one shouldn't be too confusing. If I wanted to write this one, 29, 11, 42, 29 would be 2 arrows, 9 T's. 11 would be 1 arrow, 1 T. 42 would be 4 arrows, 2 T's. Questions about that at all? Does that kind of clear up a little bit of the confusion from before?
Well, there on the first one, 29, you put your arrows on top of each other.
20. Oh, sorry. I didn't mean to. It
Okay.
doesn't really matter there.
Yeah, but if you're keeping the same format, right?
Sure.
It would.
Yeah, sorry about that. I agree.
Then how do you separate? What if? How do you know the difference if? So if you had the arrows and that's 20, how do you know that it's not?
Yes,
blue and then
yes, yes,
it's separate?
totally. Let's do one more like this one now. And then we're gonna talk about all the issues with this, all the problems. Okay, so let's do one more. Let me give you a problem. Let's do the problem. 1, 2, 3 arrows and 2 T's. And then let's do 2 arrows and 9 T's. And then let's do an arrow. I said 9, I only did 6. 9 T's. And let's do an arrow and a T. So how many place values do I have here?
3.
3. Here's one of them. Here's the second one. Here's the third one. Okay, so this is one place value here. Here's one place value here. Here's one place value here. The far right one is going to be the ones place, the units place, 60 to the 0 power. The one in the middle is going to be the 60 to the first power. And the one over here is going to be the 60 to the second power. Each number in here, I'm sorry, each number over here on the far right-hand side gets multiplied by the number 1. Each number in the middle gets multiplied by the number 60. And each number here gets multiplied by the number 3,600, right? So this
How many that go beyond that or no?
very few. These are the ones that you tend to work with for the most part. So this one, I have 32 of those because I have 3 10s, 2 1s. So I have 32 of these. How many do you have of the one in the middle? 29 of those. And how many of the ones at the end? 11. So if I wanted to come up with this number, this would be the number 32 times 3,600 plus 29 times 60 plus 11 times 1. And I got the number 116,951. Questions about that? Do you get the gist of the base 60 number system, of the cuneiform, and how to kind of switch back and forth between our number system and their number system? Okay. unless you have other questions, I'll kind of start talking about the issues with this. So there is there's a couple of huge issues, but the biggest issue that we have with their number system is there's no zero. So 0 does not exist at this point. We don't use the number 0, or they don't use the number 0 at this point. Why does that matter? Why is the number 0 important? Because honestly, if you think about it in a kindergarten perspective, 0 is not that important, right? Or like when you're teaching, if you have young kids, like a 3-year-old, the concept of 0 doesn't really make sense to them, because when they're counting 1, 2, 3, 4, 5, and they never say the number 0. So honestly, you like have to teach a 2-year-old or a 3-year-old is like 0 is when you have something and you take it away and there's nothing left, right? So you kind of have to like connect the number 0 with the idea of nothing. Why is it important?
Well, zeros become important whenever you start multiplying and then involve negatives and stuff.
I agree. It definitely is very important with negatives. Why is it important with this notation right here?
I mean, I would say because you start with nothing.
So the idea is, what if I wanted to say, this is my 60 to the 0 power place, but I wanted this number to represent the 60 to the 2nd power? What if I didn't have any of the numbers here?
Like if your number was 116,940.
Sure. Yes. That's a great example. That's a much better example than what I was trying to do. I was trying to make it way harder. She said, what if your number, thank you for mathing that out for me. What if your number was 160,940? How many pieces would I have left over here? Yeah, I wouldn't have anything here. So this would be gone.
But you would have
this would be gone.
So
but once I take that off, doesn't that look like the ones place, and that now looks like this place value? Okay, so that's the idea. Is the reason why 0 is so important for number systems is it's not just nothing. It is, and that's a very, very important part of 0. But the other half that's the most important part of 0 is that it's a placeholder. We use 0 as a placeholder all the time and don't even realize how important it is. The difference between the number 31 and the number 301. There's a huge difference in those two things, right? If I had 31 cookies or 301 cookies, that's both terrible, but 301 would like make you so sick, right?
Saying that they can't write numbers if it has a place.
I'm saying it's confusing to write numbers if they didn't have a placeholder. So for example, I'm going to make a super simple number. Let's have this. Sure, let's just do that. Super easy. We have a lot of options for that number. Let's pretend like there's no zeros in that number at all. If there's no zeros in that number at all, it's 11 in this place value, 60 to the 0 power, which is the ones place value, and 11 and 60 to the 1st power, which is that. So we could say this number is 11 times 60 plus 11, which would be 676. Agreed? But technically, couldn't you also say the 11 could be in the 60 to the 1st power spot? I could have a 0 in this spot right here. And then I could have an 11. Nope, I did that backwards. 11 here, and this is in the 60 to the 2nd power spot. Isn't that the same exact notation you would use to write this number and that number? Since I don't have a 0 to put here. Like it could have 100 zeros after it. Like you don't know the difference between the two. Yeah? Do you see the difference? Or do you see the importance of it? No? Okay, so what if I tried to write the number 301,000 without zeros? How do I write the number 301,000 without zeros? There it is right there. That's not 301,000, right? Same thing here. I don't know what it is. I don't know the difference between those two numbers because I don't have a 0 to show me that. So that's why zeros are important. It's a placeholder to show this number is supposed to be in the ones place. This number is supposed to be in the tens place or whatever you want to call it. This number's supposed to be in the thousands place. This number's supposed to be in the hundred thousands place, and I put the zeros to show that. Does that make sense? Okay. So if you don't have a placeholder of 0, issues occur. Because also another version of this problem is it could be those two also. What about if the 0 is in the middle? This could be 11 in this spot and 11 in this spot. And with nothing in that spot. Like there's lots of options of the things. Does that make sense?
Does that not mean that there's certain numbers that they can't show?
Okay, so let's kind of talk about, this is also 3500 BC. Okay, so the idea is we use numbers, I mean, with technology especially, we need very accurate numbers for just your cell phone to work, right? This is also a different context. So the purpose of them using numbers actually had a lot of meaning behind it. And usually you could use context to tell the difference between the numbers. And let's kind of use this example to show. This number is the number 676. If I just had it in those two place values, I have 3 versions of this number, right? This number would be 11 times 3600 plus 11 times 60, which is supposed to be parentheses, which would be the number times 3600. 11 times 3600 plus 660, 40,260.
And some numbers in context just don't make sense.
Yes.
They're trying to tell someone.
Yes.
676 sheet.
Yes, versus
They're not
40,000.
sheets.
Sure. So yeah, the difference in their numbers, because their place values are so huge versus our place values, the difference between 31 and 301, if you're saying, I don't know, I'm trying to come up with an idea that the both of those would make sense. I owe $31 or I owe $301. Those both make sense if you're talking about going grocery shopping, right? Right now it's more $301, unfortunately, but it's like I paid this, both of those numbers work. Down here, I paid $676 or $40,260. It's obviously this one for groceries, not that one. Does that make sense? So because they didn't have this placeholder, 0 as a placeholder, they did a couple things. One thing they did was use context to determine the number. And also remember, use context to determine the number. We're doing a lot of math to come up with all these numbers. Again, they're just looking at numbers. They're looking at it and seeing 31 or 301 and saying, oh, it's obviously 301. Okay, so they're not like mathing it out every single time because this is like normal to them. The other thing is sometimes they would leave a space. So if they wanted to do the version of the number like this with the 0 in the middle, they'd probably leave a big space right there to show a space for the 0 in the middle and then this number over here. The problem with the leaving the space is that things get recopied over and over and over. And as they get recopied, what if it got put closer and closer together and the space just goes away? Okay, so this is an issue in like recopying. I say recopying, I think that's copying would just be the correct word there. When copying a new tablet. So in 300 BC, so again, this is like 3500 BC, so this is a very long time later. This issue became such a big deal that they created placeholder. So the symbol for a placeholder was either 2 of these or 2 of these. Like we're not gonna ever really need to write this or whatever, but they did come up with they did come up with a way to create a placeholder. But again, that wasn't the number 0. Like 0 was not created or used or invented or discovered, whatever word you want to say, for a really, really long time. So this became a placeholder. The only thing though is it wasn't used at the end of a number. And I think the reason why, and this is all speculation at this point, but I think the reason why it wasn't used at the end of the number is we talked about the difference in their numbers, like context was used. Like this number is so much bigger than this number that it's pretty obvious that we're using this version of the number. Okay, so we still have a little bit more to go, but summarizing all this. In general, comparing the Egyptian number system with the Babylonian number system. It's more efficient because you don't have to draw all those characters like 9 times, 8 times, 10 times or whatever to make a number. Like we've dealt with much bigger numbers. Think about like to do 116,951 and draw it in Egyptian hieroglyphics, how terrible that would be. So this is a much more efficient system. It's also positional. Okay, so if you were going to compare Egyptians with Babylonians, just specifically talking about their number systems. This one's more efficient. This one is a positional number system. This is a non-positional. Do you remember the other word we used for the Egyptians? We said non-positional, and there was another word we used. It's an additive system because you have to add all the pieces together to get your answer. Like you literally have to count how many things you have and add it up to get your answer. Okay, so let's talk about fractions with the Babylonians. And then next time we'll talk about fractions with the Egyptians. Babylonian fractions are actually much better than the Egyptian fractions. So fractions with Babylonians. So the first way that, before I do that, let me go back to base 10. So fractions in base 10, we usually use decimals to represent this, but the idea is if I put a decimal point right here, what would the next place value be here? What's the name of the place value? How about that?
Tenths.
The tenths place. This is it's 10 to the negative 1 because it's 1/10. It's the tenths place. And then this would be the hundredths place, 10 to the negative 2. And then the thousandths place, so on and so forth. So if I wanted to put a 1 in the tenths place and a 2 in the hundredths place, how would I write this decimal 0.12 as a fraction?
12 over 100.
12 over 100, right? Because it's 12 in the hundredths place, so it's 12 hundredths. You could reduce that down to 6 over 50, 3 over 25, right? It's the same idea with the Babylonians. Their fractions, again, if this is 60 to the second power, 60 to the first power, this is 60 to the 0 power. Instead of a decimal, like we used commas, remember we used commas to separate these? We're going to use a semicolon to show we're now going into fractions. So this would be 60 to the negative 1 power. So whatever number's in that place value, you put it over 60. So this is going to be a 60 on bottom of a fraction. Like 1/60th. Does that make sense? So if I had, let's say, let's do 25. 1, 2, 1, 2, 3, 4, 5. Sorry. That would be the fraction 25 over 60. And you can reduce that to 5 over, all right, how many times?
12.
Oh goodness, I had a moment I couldn't divide for a second. 5 over 12. That would be the fraction 5/12. So if you want to convert a fraction into So once we learn more fraction stuff, like next week, we can revisit this, but for now, the way we're gonna do this, if you wanted to take the number 1/6. The idea is you need to convert that into some fraction over 60. How do I make that into a fraction over 60? Multiply by 10, so it'd be 10/60th. So yes, this would be the number. If I wanted to write 10, it would just be like that. The semicolon and then the arrow. Does that make sense? If I wanted to do the number 1/2, I need to make that into some fraction over 60. How do I make it into a fraction over 60? Multiply by 30. So it'd be 30 over 60. So this would be the fraction. 3 of those. Does that make sense? What about if I wanted to do 1/4? You have to multiply by 15. So 15 over 60. So 1, 2, 3, 4, 5. Does that kind of make sense? Okay, so why 60 is the big question. Why in the world did they do 60? We have 10 fingers. That's what we talked about. Like we do base 10 a lot because we have 10 fingers. So why would I pick 60 as my base? So as you can see from some of these things, 60 is divisible by a lot of numbers. Let's think through the number 60 is divisible by. So 60 is divisible by what numbers? 1, 2. Is it divisible by 3? 3, 4, 5, 6, not 7, not 8, not 9, 10 would be the next one, 12, 15, 20, and 30. That's a lot of factors for a number. Because generally, like think about our base 10 system, what numbers is 10 divisible by? 1, 2, 5, 10. That's it. You can't divide it into fourths. You can't divide it into whatever, 7, 6, thirds. So that is one reason why we think they used a base 60 number system, is especially with fractions, it's real nice because you can easily take all these denominators and turn it into a 60 on bottom. What in our number system in our lifetime do we use that is still base 60? If Jamie was here, she had me for
Time.
1350. Yes, good job. Time is base 60. I am not a questioning person, so it never bothered me, but some people question all the time. Why is 60 seconds in an hour? 60 seconds in a minute. Why is 60 minutes in an hour? So on and so forth. And the reason why is because if it wasn't 60, let's say it was base 10, let's say it was 100. Think about what a clock would look like for 100. Does it divide nicely? I mean, it divides nicely into fives. You'd have to have 20 all the way around, but it wouldn't divide by 4. Does 100 divide? Oh, no, it actually does divide by 4, but it doesn't divide quite as nicely this way. Okay, so 60 seconds, 60 minutes divides nicely into 12 sections. You can have fifths, you can have fourths, you can have halves, like quarter hours, half hours, so on and so forth. So that's the reason why I think we use time as base 60, as 60 seconds in an hour, 60 seconds in a minute, 60 minutes in an hour, is because your clock works out well that way. Because you can have fourths, you can have sets of 5, so on and so forth. It just divides nicely. So there's a little tidbit for you if you've ever wondered why time was that way. Another reason why we think that they might have used 60 as their base is possibly they were able to figure out that a year was close to 360 days. Oh, sorry, I can't spell very well. And so that would be a nice way to express months, years, whatever.
Just out of curiosity,
Go ahead.
did they come up with the number system and then a calendar system, or they come up with a calendar system and then a number system?
Good question. I actually don't know the answer to that. At one point in the semester, I'm gonna make you pick a topic and do a little bit of research on the topic and a presentation. And last year, somebody did calendars and looked at calendars for different people groups. And because like we'll talk about this next time, but like the Chinese people, calendars were really, really important to them because they have monsoon season. And so they needed to be able to project like monsoon season is this time period. So I have to make sure we get all our crops in by this and so on and so forth. So for certain people groups, the calendar was more important than for other people groups, like versus like the people who live in the desert, like it's just hot all the time, you know, like year round, it's more of a similar temperature at that point. So I don't actually know the answer to that. I'll look it up for you. I'll write a note to myself to look it up. Okay, so we're going to stop there. We still have a little bit more to talk about the Babylonians, and we'll do that next time. But you can go ahead and start with your homework. So here's the homework. You're doing 1 through 5. So like number 1 is these are base 10 numbers. Turn them over to cuneiform like this. So that means you have to switch them. It's kind of like what we did here. Let me pull this back up. So starting with the number 257, write your answer like that. Starting with the number 5,287, write your answer like, oh, I did the wrong one. This one would be that. This one would be that. So we did that. It took us a little while to get there, but that's the idea is you're starting with these, you're ending with the cuneiform. Go ahead and do both, like the number with the commas and the cuneiform, just in case you make a mistake on the cuneiform. So that's number 1. Number 2 is the opposite. Given that, go back to the numbers. And then for number 3, start thinking through that. The writing fractions. Think through how you would do that. And we'll pick that up next time. Number 4 is very similar to number 2. It's just written with commas this time. And so there's some fractions in there this time. Like 4B, 12 is in the 60 to the 0 power place value. So that'd be the number 12. And then you have your semicolon. So this 3 is in like your 1/60 place value. What would 45 be in? 1 over what?
Is that 45?
It's comma 45.
One over.
It was, so we said like, oh, sorry. I meant to pull this up. Where's that at? So we just wrote that. Oh, so this is the first number. Sorry, I'm trying to pull that up. The first number was in this place value, 1/60. What's this next place value going to be? If I had another place value, it'd be 60 to the -2. That would be a number over 3,600. Okay, so if you want to start that, you can. We'll do more of that next time. And then number 5 is take this number and multiply by 60. This is like a pretty simple problem. It's going to seem hard at first, but it's going to make more sense as you start doing it. So if I were you, I would at least try to get through 1 and 2 and maybe start number 3, and we'll cover more fraction stuff next time. Questions about anything? Okay, well, I will see y'all on Thursday. Let me know if you have any questions about anything. And that Egyptian homework's due on Thursday, right? Okay.